Hi, welcome to your second lecture of learning programming fundamentals using Java language. So in this lecture, before starting and getting a hands-on experience of Java code, I want to just briefly introduce you or want to show you like what is the responsibility of JVM and how it works to run your code and then compile that and send that to your machine for execution. So for explaining that, I already write couple of components. You can see that on my screen just to save some time. So this JVM stands for Java Virtual Machine. There is another component that is called Java C, which is Java compiler, and as I mentioned in my first lecture, is typically written into your C language. And then this is a piece of code which we want to execute. So what happened is basically how this process works is basically you pass that code and that code is read by your Java standard Java compiler. And what that compiler does is basically it read that code and then convert that code into another language which we don't able to understand. That language is specially made for your JVM to understand. So JVM is the component which exists in JRE, which we discussed in our first lecture, and JRE is the part of JDK. So JVM is able to understand that language, that particular language, and that language is called bytecode. Now, before going further, I just want to emphasize that what I am explaining here is basically the behavior of Java, which we called Vora, write once and run anywhere. So how this magic happened is you have to write your code into a system and then you can run that code into any sort of operating system. You don't need to rewrite it again. You don't need to change your line of codes. It will be the same, and then it will run perfectly on different operating system. So what happened is basically when you write code, it read by Java compiler, convert into intermediate language which is called bytecode, and then it pass to JVM. Now all magic happened inside your JVM. Now this is where things exist, where basically things exist which basically convert those bytecode depend upon operating system. So in interviews as well, there is a very common question which is always being asked, that Java is a cross-platform, and we always say yes, Java is a cross-platform, it's not platform dependent. But when your interviewer asks you question that is your JVM is a platform independent, then answer is no, because our JVM is not platform independent. That's why when you are going to install your JDK, you can see that JDK is available for all different operating systems. It's available for Windows, it's available for Mac, it's available for Linux, and then you have to download your JDK depend upon your OS. I will show you how it does. So why these JDK and JVM are different from different operating system? It is because Sir James Gosling, when writing this Java language, they decided to write this intermediate software, this JVM, which basically help us as a translator of translating your bytecode or compiled code to your operating system. They write that differently for different operating systems. So they wrote different instructions in JVM for Windows. Just for easy understanding, hypothetically, just consider that they wrote different instruction of JVM for converting your code to Windows, and then they wrote different instruction for JVM for converting your bytecode for Windows, for Mac, and then for same for Linux. So that's why when you pass your bytecode, before that conversion of code with Java compiler to bytecode, this complete process which I'm highlighting here is same for all operating system, but the process afterward is different from all operating systems. So JVM is going to convert those bytecode depend upon on which operating system we are running our Java environment to that particular machine language. So what it does is basically it read bytecode and then it basically convert those bytecode into machine language and then run basically on that particular machine. Now it's not that simple and easy to read bytecode and then basically run convert into machine language and then start running, because inside JVM there are a lot of processes which are included. For example, like there are some of the typical class loader which are included there. Then there is a lot of memory management happening, and then there is two components. One is called interpreter and just in time compiler. I'm just going to write it here, interpreter and just in time compiler, and they are basically dealing with this bytecode and converting those to your machine language before execution. So it's like a super advanced topic. Like we can make a separate lecture on JVM and understand its internal architecture and see how things are going there. But just for the understanding, just for the basic level of understanding, is like your code your Java C and your bytecode will be same for all operating system. Then you will have different JVM which convert your bytecode depend upon the operating system and instruction on which JVM is created, and convert those into machine language and run them. So this is all about JVM. Now let's see what we have to do to run our very first application in Java. So you need to just download JDK first. You can just write on Google JDK download, and you can see that there is an Oracle website which provides us different type of JDK. And as I mentioned before, that JDK are different for all different operating system, and that is a proof that we have different JVM for different operating system. Like Linux will have its own JDK because JVM is different from Windows One. And why it's different? We already see that why it's different, because it have to convert bytecode to machine language depend upon the operating system, because each JVM will have different instructions. So for Linux it will be different, for Mac it will be different, for Windows it will be different. So you have to download JDK depend upon your operating system. So for example, for the sake of my system, I'm using Mac, so I can just download this one and then just install that. It will be very simple. Next and install. The other way of getting your JDK is to first download your IDE. So for our these lectures we are going to use IntelliJ IDE, and then you have to just download that. It's provided by JetBrains. Basically it's the same company which also provides us Android Studio for developing Android application. So you have to download that. Once you download it, then you will able to see your IDE, something like that. And then you have to create a new project. Let me create very quickly first. And then you can see that the project SDK will be here. So one option is to just download first, and then it will automatically pick your JDK for you. The second option is it will not pick, then you have to create a new application, and then while creating your new application they will also give you some option to download that on the runtime. So for example, with the Java one, I'm going to create a Java application here. I'm using JDK 16, and you can see that there is another download JDK option. While creating your Java application, you can click on that and it will already give you an option, and the version, the latest version is 18, which I showed you. There is Oracle Open JDK which we need, and then it will also automatically pick up a path and just set that for you. So we just need to download that, and that's it. And then if we can create we can proceed with creating an application. So I already have a JDK, so I don't need to install it. I'm going to just click on the next and next, and then I'm going to create a project with the name of test project 1, and then finish. That's it. So it will create some directories for me. So this is my project. You can see here test project 1. It will have an .idea directory that's basically related to ID. We don't need to worry about it. Then there is a source directory, and then there is a IML directory. Forget about that. And there are some external libraries. Remember, if you guys remember that in my first lecture I was telling you that in our JRE we will have some support for runtime libraries which we require to run our Java application code. So you can see that all of these libraries exist in this external library sections. You just need to come into this source directory, click there, and then new, and then create a Java class. In very first lecture we mentioned that Java is an object-oriented programming language. So whenever we have to write a code, we have to create a class. So let's create our very first class here. We call it hello world, and then enter. That's it. So here you can see that our class is created. You can just you already noticed that the name of the class and the name of the file which we created is the same. What is this public? I will explain that. This is called in Java that public is a keyword which is called access modifier. I will explain all of the access modifier we have in Java. It basically tell our compiler that and our JVM that this class is accessible publicly. So any class outside of this class can access this class. So they will have this access here. So we as a very first example, we want to just print hello world on our console. So for printing basically some statement there, we need to create a main method. It's the same, this behavior is the same in our old languages as well, like C and C++. So we have to write first main method, and from that main method our compiler basically start picking up our code and start execution. So writing main method in Java is a bit complex as compared to C++, but let me just write quickly and I will explain what is I'm writing. So public, there will be static, and then void, and then main, string args, and then for writing on console I have to use system dot out dot println hello world. Okay, just run quickly this application and see that if we have output as expected. So we can see our hello world here. Okay, public, as I mentioned, is access modifier. I will explain more in detail what are access modifier we have. Static, just forget about that right now, we will explain that later. We will discuss that what are static and non-static fields. Void are those methods which does not return anything. So that's a very basic concept in programming fundamentals, that if a method is void, so it means it's not returning anything. You have to keep in mind that you have to write your main method name as it is, which I'm writing right now, otherwise your compiler will not pick up that. Main method is expecting a list of string arguments as an input. These arguments are used when we want to pass an argument during runtime. I will show you with one example that how we can pass argument on our main method while calling our Java application. And then system is basically a class. This class basically comes up with our java.lang package. So Java basically have different type of packages. For example, java.util, this is another package. So package is basically a collection of classes in Java. So when you are writing a same type of classes, you usually write those inside a package. We did not create package yet, but we will create those into our future lectures. So a lang is basically a package which provide us by Java when we install all of our runtime dependencies using through JDK and JRE. So you guys are maybe thinking about that we did not use that package anywhere. So usually when you want to use something from a package, you have to import that, otherwise your class will not able to understand from where this system is coming from. So lang package have one very interesting attribute, that it's auto import. So you don't need to import that, it will automatically import it into your code. So system is basically a class which have print stream. Print stream is the part of IOStream, input output stream, which we will discuss in future. So you don't need to worry about those right now. So just consider that there is a system, then you have to write out, and this is a method println. So what println does is basically it write the statement which we pass inside this method onto console, like for example here. And after writing that statement, it also append a new line afterwards. So you can see that there is a new line after. If you just have a look on my insertion mark here at the end of hello world, if I go further, there is a new line. And to prove that, when I'm going to write another statement after that, you can see that it will goes to a new line, hello world 1 for example. And if I will run it, you can see that hello world will be in the first line, and then hello world 1 will be in the second line as here. But if we remove this println and then println, you will see that those are in the same line without appending with a new line. So just see that here, hello world and then hello world. So ln means there will be a new line after the statement. So it's mean that after hello world there will be a new line, and then the next print will be on the new line. The alternative approach of appending a new line at the end of the statement is adding /n. So we can use /n as well to indicate that there is a new line, and then the next statement will goes into the new line. We don't need to write ln in print, but just to add and append /n, and then it will create a new line. So that's it for the today's lecture. This was just to give you a brief overview and to just write our very first program into console and just try to install everything. If you have any question, feel free to comment out and ask, and after setting up everything we will go and see further. Thank you so much.